So now that you guys have completed the warm-up, I want you to go to this section of your notes where it says examples of composites. We're going to talk about the earliest examples of composites, go into ones that are very popular, and then go into the fiber reinforced composites where it gets more advanced and you see ones that are used for the industries that we talked about in the previous class. So open up your note packet and you will first see the earliest example of composites is going to be mud and straw made into bricks. So in ancient times, this is the first really man-made composite that we know of. So mud and straw were used before actual bricks were used, but they were made into a form of a brick to build sturdier or stronger buildings. So at first, people tried to put mud together to build a house, and then they tried to build a house with straw and realized these things by themselves don't really work and make a sturdy building. So they combined the two and made a composite of mud and straw, and it seemed to have both of the properties of mud and straw together, but it created a stronger building and a more sturdy brick to make a house or any kind of building that people would need to live in. So this is really the first example, and it's very old and can still be used today. Usually we have better techniques now that other things have been made, like another common example is wattle and daub. It's the first type of concrete method. So what I have underlined is what you should put in your notes for this section. So wattle and daub is really wooden strips mixed with clay, wet soil, sand, and straw to make bricks. And this method is over 6,000 years old. So the mud and straw method was way older than 6,000 years old. And then we come into adding different wood and clay in sand into the old methods, and it makes a more durable kind of brick to build a house. And then we get into making concrete, which is aggregate or small stones or gravel, and it is bound together by cement. So cement is added, or we add these small stones or gravel into cement, and it makes concrete. And concrete is a good way to build houses because it's inexpensive and it provides good strength when you are putting compression onto the concrete. So, for example, when you put your roof on your concrete house, it is good. The house doesn't fall down. That concrete doesn't break. It has good strength, so it will not tumble down when you add things on top of it. And even it can be made stronger by adding different things like metal rods, wire, or cables in the composite. So like some houses are they even use steel beams to make the house better or make the concrete more strong and make sure that the house doesn't fall or crack under tension. The next type of composite that really is very popular that came probably in the next time period would be plywood. You probably heard about this, and this is why we talked about wood first in the last chapter, so then we could talk about plywood. So plywood is really just wood glued at different angles, giving better properties than, say, a natural wood that you would take off a tree and just cut to sell at Home Depot. So, plywood is resin and wood fiber sheets together to make their composite or make the composite. And there are different pros to using plywood over a different type of wood. So, plywood can be resistant to rot, weatherproof, and is dimensionally stable. So, a lot of people use plywood because it is weatherproof and it won't rot outside, and it is very stable, and this can also save different rarer trees that are kind of not found at Home Depot from becoming more extinct. So, for example, a lot of the wood I gave you guys for that project at the beginning of online learning, a lot of you put that you can't find it really anywhere at Home Depot or Lowe's because it is very expensive and it's not sold at those places because it's found less and less or found in only a certain area of the world. So plywood saves those trees or that wood from um, being used up. So I am going to show you, I looked up plywood online. I don't know if you guys have ever seen plywood. It is at Home Depot, and you probably, if you do any construction at your house, have plywood around. I know I used plywood I used to have a bunk bed, a wooden bunk bed, and it was underneath on the top bunk of where you put your mattress. It was right underneath there. So one thing they even just have right on their website is that it's sustainable, paintable, pressure treated, and you could have different grooves on the plywood. And it also um, gives you a reason to choose plywood. It's a popular choice for residential and light duty construction, and explains that it is made of veneer that have been peeled from debarked wood. And they're glued together in alternating perpendicular directions to create a cross graining pattern. And that pattern makes it so strong and stable. So that's kind of cool that you can just go onto Home Depot and kind of see why we're learning what we are learning. Another specific example of composites is paper mache. And you might have completed paper mache in your life before through art classes or just for fun at home. So paper mache is a composite of paper and glue, and it's been used for hundreds of years. It's used in different building material for traditional and ceremonial events, as well as simply in arts and crafts, like at school in art class, or if you just are doing crafts at home. On the left, this is actually a picture of a building in, I think it's either Japan or China, that is made strictly from paper and paper mache. And on the right, this is a structure that is seating at Coachella in 2015 that is made from paper mache. So it's the composite of just paper, glue. When you would do paper mache as a kid, you would just keep layering the paper and glue together. You would soak the paper in the glue mixture, and it would eventually harden into a stronger material, because putting those two together, that glue will dry and the paper will still be clumped together with the other papers. So that is another example of a composite that you might have not known was a composite. So the next many examples that we're going to go over is fiber reinforced composites. There are different specific examples that have different uses, but we're going to go over what fiber reinforced composites are as a whole first. So this picture I've added a couple times, I think, in the notes, and it we've already talked about how composites are made up of a matrix and a reinforcement. So this type of composite is made from fiber reinforcements. So the fiber reinforcement will have properties that deal with high strength, high stiffness, and low density. They will be added to a matrix that has low density and good shear properties. When combined to form the composite, that new material with the two materials, the reinforcement of the fiber, the matrix together, that composite will have now high strength, high stiffness, good shear properties, and low density. So those two are coming together to make a new material, and it has all properties of both of the fiber reinforcement and the matrix. So, the types of fiber reinforced polymers that we are going to talk about and you will need to know are carbon reinforced polymers, glass reinforced plastics, thermoplastic composites, metal matrix composites, and ceramic matrix composites. I think we're only going to go over carbon reinforced polymers today, and then we will go into the rest of them next class. So, there are many more different fiber reinforced polymers, but these are the most important. I'm only going to make you know these types. So these fiber reinforced composites have gained much popularity in high performance products, just like within the advanced technology that I talked about, or I made you guys watch a video on last class. Those were these fiber reinforced composites, and they are used for many of the industries that have come about with automotive, aerospace, any of the newer industries with high performance products. So overall, the fibers are used in these composites. I kind of already explained this, but they have high strength and high stiffness and a low density, while the matrix has good properties and a low density. When you put those two together as a composite, they will have properties of the fiber reinforcement and the matrix. And that was just me explaining that picture over again. So I would just even write down that picture in your notes if you have any space, because that is a good. So the composite as a whole will have the properties of the fiber reinforcement and the matrix. I don't know if I got cut off in the last one, but I explained that in the picture. So if you want to jot that down, I would. So fiber reinforced composites gained much popularity and in many industries, and they are so popular and are used in high performance products because they are lightweight, strong, and take on harsh conditions. But one little drawback that we face is that these fiber reinforced composites, since they are so lightweight, strong, and are able to take on these conditions, they are expensive. So these really describe why they are used, but that is one drawback. Usually composites are inexpensive, but this type of composite is expensive because of the materials that are used and just the time it takes to test all these products. The first example we are going to talk about is carbon reinforced polymers. So we talked about polymers in this class. Polymers are another term for plastics. So it is plastic or polymer, a matrix with carbon fiber reinforcement. And carbon is an element and is really the same element that's used for diamonds. Really, carbon is diamonds and graphite. So Carbon is used as the fiber reinforcement. So this composite has properties of polymers and carbon together. So this carbon reinforced polymers are also expensive. They're strong yet lightweight. They're also stiff. So these this type of composite is used for aerospace, marines for boats, automotive for cars, civil engineering for different bridges, sports equipment, and it has, over the years, it has an increasing number of consumer and technical applications. So this is a picture of a carbon reinforced polymer that is a helicopter wing. It is a carbon reinforced polymer. You can tell because it is strong yet lightweight, and it is also stiff, so those don't bend. And a lot of the examples that were talked about in the last video I made you watch on NASA, a lot of those were fiber reinforced composites, and you would see carbon reinforced polymers at that NASA space area. They would use this composite for their um, aerospace and airplane models, like they were showing in the film. So we're going to talk about this glass reinforced plastics next class. So you will only need the previous notes for the worksheet that you will have on Classroom. And this worksheet will be due by the end of the period. I'm going to add some pictures to the following notes so you guys can see what I mean by glass reinforced plastic. And that is all you need for the worksheet and the following warm up that will be next class. So if you have any questions on these notes, let me know. We will go over the rest examples next class. And we only have, after this class, 9 more. So make them count. Keep watching these videos and asking me any questions if you need to.